There are k positive integers where b is between 5 and 2024 inclusive, such that the base b integer 2024 is divisible by 16, where 16 is base 10. What is the sum of the digits k? A very quick primer here for those of you who are unfamiliar with bases other than 10. When I write a number like 45, it's always, this is base 10. But we don't actually even say that it's base 10. We just assume that it is. We don't even write this base 10, right? But what is 45? It's 45 times 10 to the power of 1. Sorry. It's 4 times 10 to the power of 1 plus 5 times 10 to the power of 0. I gotta learn base 10 myself, I guess. And that's how you get the 40 plus the 5, which is 45. Very similarly, if I gave you a larger number, say 3724, and I said, what is this in base 10 if you were to write it out? Well, okay, it's 3 times 10 to the power of 3 plus 7 times 10 to the power of 2 plus 2 times 10 to the power of 1 plus 4 times 10 to the power of 0, right? We're used to that, so we don't write base 10, and we certainly don't write the number like that. But base b, so for example, if I have 2024 to the base b, you can see there's a little b there that's microscopic, but you can see it. What does that mean? Well, it means the following. Base b would actually be the following. It would be 2 times b to the power of 3 plus 0 times b to the power of 2 plus 2 times b to the power of 1 plus 4 times b to the power of 0. You got it? So in this particular case, that simplifies to 2b cubed plus 2b plus 4. This is the value of this guy. And they're saying that this is divisible by 16. So for the sake of simplicity, if I divide through by 2, it'll be b to the power of 3 plus b plus 2. This guy would be divisible by 8. I think it'll make it a little bit easier to work with that. And then what they're saying is that for this range, for all the numbers that are between 5 and 2024 inclusive, for which values of b is this true? This. For which values of b is that true? So that's a lot of numbers. I mean, from 5 to 2024 inclusive, that's like 2020 numbers. And obviously, we're not going to go through every single one. So what I think you have to do in this question is you have to look for a pattern. And let's see. So let's start. Let's start with a value for b. Let's start with the value for this b to the power of 3 plus b plus 2. And then let's say, is it divisible by 8? Yes or no? Yeah. Let's say that. Let's make that table like that. And then hopefully we'll find a pattern sooner rather than later. And then we'll go from there. Okay, so we'll go 0, 1, 2, 3, 4. Does it say anything about positive, negatives? K, yeah, the positive integers. So, yeah, I got it. Okay, so 5, 6, 7. Let's just go up to 7. Let's see what happens, and then I'll continue after that. Let me just see first of all. Well, first of all, if we put the value for 0, we get that. Is this divisible by 8? No, of course it's not. 1, we get 4. That is no. 2, we get 12. Again, no. 3, we will get 32, and that is a yes. That is divisible by 8. 4, well, you can continue, but this is no and no. And then 6, I believe, is 224. That's a yes. And then 352, that's a yes. Now, what's interesting is that if we continued with this list, and I want to do it side by side here. because if I go next to a value for b of 8, the reason I put it side by side is because this b equals 8 is the same as 0 mod 3. And therefore, it would have the same result. Same thing as if b equals 9, this is the same as 1 mod 3. And therefore, it would have the same result. And if it's 10, it would be the same as 2 mod 3. You see what I'm saying? 11 would be the same as 3 mod 3. 12, 13, 14, and 15. 14 and 15 would be the same. Well, 14 would be the same as 6 mod 3. And 15 is the same as 7 mod 3. So therefore, the result, which is the all-important result, the divisibilities would be the same. So that means for every cycle of 8, you're going to actually get 3 guys that will satisfy our condition. So, for example, from 1 to 8, for values of b, you get 3. And those 3 in particular were b equals 3, b equals 6, and b equals 7 from the table. And then when you go to the next group of 8, oh, sorry. This was 0 to 7, right? Yeah, 0 to 7. This should have been 0 to 7. Sorry about that. And then the next one is 8 to 15. That would also give you another 3. And in particular, we had calculated that as 11, 14, and 15 from our list. This was 11, this 14, 15, and so on. You just kind of keep going like that. Dot, dot, dot. You keep going. And eventually you get to the last 3, because we're going all the way up to 2024. So you'd go all the way up to 2017 to 2024. Those final 8. 17, 18, 19, 20, 21, 22, 23, 24. And for those, there's going to be 3. And those ones, I can figure this out. It'll be, if you want the actual numbers, it'll be it will be 2019, 2022, and 2023. Yeah. So that means we have a whole bunch of, groups of 3s. So how many groups are there? 2024 divided by 8, because each of these are groups of 8. So the total is 2024. So 2024, let me just do it on the side here, divided by 8. That's how many groups we have. So that's 253. So we have 253 groups of 8, and for each group we have 3 that would satisfy our equation. Yeah, so that's 759. That's how many values. But here's the thing, this is a tricky question, that b is for between 5 and 2024. So it's not between 0 and 2024. So some of these guys, well, not too many, just this guy is disqualified from being. So from this 759, we have to take away that guy. We have to take away 1. So that actually, yeah, let me write it here. Because b is between 5 and 2024, b equals 3 does not qualify. Does not qualify. Whatever you want to say. I mean, this is not a long answer question. And you just have to find the answer and circle it. But I'm just saying for the sake of completion. So this actually becomes 758, and this is what is represented by that k, this k here that they keep talking about. And then they want the sum of the digits of k. Okay, sum of the digits would be 7 plus 5 plus 8, and that's 20. So 20 is the answer to a pretty challenging question, actually. D. The first 3 terms of a geometric sequence are the integers a, 720, and b, where a is less than 720 is less than b. What is the sum of the digits of the least possible value of b? Okay, so geometric sequence, right? Okay, so geometric sequences are of the form AR squared, AR cubed, and so on. And the first term over the second term is equivalent to the third term over the second term, like that, and so on. And as you can see, all of these are basically just R. So we're going to use that. So our terms are A, 720, and B, correct? Okay, so that means that 720 over A is the same as B over 720. So that means 720 squared is AB. All right. And we need to, what do we need to do? Oh, the least possible value of B. Okay, so, and then we're given something. So this is an experimentation question. I don't think there's any formula here. So the first thing I have to do is break up this 720 into its prime factors. 720 itself in prime factors: 2 times 2 times 2 times 2 times 3 times 3 times 5, and then it's all squared. That means that AB, that's 2 to the power of 4, so if it's squared, it would be 2 to the power of 8. That means 3 to the power of 2 squared, 4, and then 5 squared. Okay, so that's the grand factorization of that number. And we want B to be as the smallest possible, least possible value. Okay, so since B is greater than 720, let's see if we can get a number close to 720. And then eventually, what's the sum of the digits? They're being tricky here. They didn't actually give me the value of B, because if they did, then it would be much easier. Well, I mean, yeah, it would be much easier, but they didn't give me the value of B. They gave me some of the digits. Okay, so they made it hard. Okay, so, well, the first thing I thought is we just have to fiddle around with that. So B is obviously a component of that. Since A times B equals that, B is part of, that number. So how about if we just took out the 2 to the power of 8? I'm just experimenting here. That's 256. That can't be B, because B has to be greater than 720. But what if I multiplied that by just 1 3? Then that would be 256 times 3. And that would be 750 plus 18, so 768. That's fairly close to 720. So that's my candidate for the B, because I don't think you'll get any number that's less than 768 and greater than 720 if you're looking at this inequality. So if that's my candidate for B, what are the sum of the digits? 7 plus 6 plus 8, and that is 21. 21 is E. The graph of y is equal to e to the power of x plus 1 plus e to the power of minus x minus 2 has an axis of symmetry. What is the reflection of the point -1.5 over this axis? So what I would do is just make a quick sketch of it. E is equal to 2.7 or something. And when you do, this is what you'd get. Now, the red dashed line down the middle is the axis of symmetry. And that axis will help us figure out the answer to this question. So they're saying you take the point -1.5. Okay, so where's -1.5? -1 is here, and 1/2 is here. So it's approximately there. Now, when you reflect that across that axis of symmetry, it's going to land all the way on the other side. And that looks like it'll land right there. And that point is 0.5. And that's basically the answer to the question. The numbers in order of each row and the numbers in order of each column of a 5x5 array of integers form an arithmetic progression of length 5. The numbers in positions 5, 5, 2, 4, 4, 3, and 3, 1 are 0, 48, 16, and 12 respectively. What is the number in position 1, 2? Okay, I'm going to have to draw this a little bit bigger. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on, because that is way too small for me to fit in what I need to write. Okay, so these are the 5 by 5 numbers, and our task is to figure out this one, I guess, the one that they have called a question mark. And then let me see if I can fill this in properly. That's a 48, that's a 12, that's a 16, and that's a 0. Okay, all right, that's all they have given me. And then this is a very important point, that it's an arithmetic progression. So what that means is that you have a plus d as the next number, a plus 2d as the next number, a plus 3d, and so on. Now, if the first one is a, I'll just call this one b and c. There's several properties, right? And one of the properties is that if you add a and c, it would be 2a plus 2d, which is basically double of b, right? So b would be equal to a plus c over 2. And you can see that that is true. A plus c is 2a plus 2d. And if you divide that by 2, it will become a plus d, which is what b is equal to. See? So we're going to use this property actually over here, and hopefully it'll help me. Okay, so let me move this up a little bit. Okay, so the first thing I have to actually decide where do I go here. And that's a challenge in itself. Let me try this one here, this guy. And And I'm going to start at the center. I'm going to put an A there. Yeah, I think starting at the center will help, because I need actually two numbers to try to get this to work. So the x would basically be, if I use that, it would be a is equal to x plus 16 over 2. Correct? Yeah. So x would basically be 2a minus 16. 2a minus 16, yeah. So this is 2a minus 16. There's no tricks here. I'm just using this guy here. Okay, so where do I go from here now? I've got to figure out what can I use. I'm going to try to focus on this one here. So I'll just call that y for now. So again, using this guy, and let me think about this. It would be y plus 48 over 2 is equal to 2a minus 16, right? So then I've got to isolate for y. So that would be 4a minus 32 minus 48 is y. So that would be 4a minus 80. So this is 4a minus 80. Okay, so far so good, I think. Now we'll concentrate on that box that they have called the question mark. Okay, and because or can I? Let me think about this. Oh, I need this guy first. This guy here. So that should be fairly straightforward. That's just going to be 12 plus a over 2. Yeah. Okay, now I can concentrate on that box. That box, which they have called a question mark, plus 12 plus a over 2, all over 2, is equal to 4a minus 80. Yeah. Okay. And that should allow me to get the question mark, at least in terms of the a. So let's see here, multiply through by 2, so question mark plus 12 plus a over 2 is 8a minus 160. And then question mark, let's multiply through by 2 again. 12 plus a, 16a minus 320. And then 2 question mark would be 15a minus 332. And then finally, question mark would be 15 over 2a minus 166. Okay. 15 over 2a minus 166. Oh boy, I don't think I can fit this in. We'll just put question mark here. and the question mark is down here. What was it? This guy right here. So it was 15 over 2a minus 166. Okay. All right. Now, what's the last step here? I still have to get a number. I have it in terms of a, and I need a number. So how do I get a number? That's an interesting thing. How do I get a number here? I have to read the question again. These are the values of what a question mark could be. Okay. You know, I think I have to try different values of a. And it's positive, right? Well, it doesn't really matter what the question says. All the answers choices are positive. So let's see. It has to be positive. So let's see what if a was 20. Well, this is 7.5. Let me just make it 7.5 plus, sorry, minus 166. 10 would be 75. 20 would be 150. I've got to be more than 20, 22, 20. Let's try 24. I think that's the first time it'll probably be positive. And if I do that, and if I sub a as 24, this becomes 14. Okay, 14 is not an answer. All right, let's keep going. I'm going to have to use even because they're all integers up here. The answer choices are all integers, and this a has to be even in order for the final result to be even, right? Because it's 7.5. Let's try 26. If you do that, you get 29. 29 is one of the answers, but let's just see what happens if I keep going. Another even number was 44. Okay, 44 is not one of the answer choices, and then, of course, the numbers would be more than 44. So I got it. It's 29, and you had to actually try different values of a, which is a bit challenging, I think. So anyhow, C is the answer. The roots of x to the power 3 plus 2x squared minus x plus 3 are p, q, and r. What is the value of p squared plus 4, q squared plus 4, and r squared plus 4? Okay, so I am going to use Vieta's formula. And in this case, this is actually a cubic. So we have an equation of the form ax to the power 3 plus bx squared plus cx plus d. And in Vieta's, the sum of the roots can be calculated with just minus b over a. So if the roots were r1, well, in this case, the roots are pqr, so that would basically be the equivalent of p plus q plus r. The product of the roots, using Vieta's on a cubic, is minus d over a, corresponding to that equation and those coefficients. So that would basically be the equivalent of p times q times r. And the sum of the products, which would be the equivalent of pq plus pr plus qr, that is c over a. So we will apply those to this equation. And when we do, we get minus 2 here, minus 3 here, and for this guy we get, I believe, negative 1. Let me just double check if that's right. I think so. Okay, so now we turn our attention to this guy, and we'll expand it all out. So we have p squared plus 4 times q squared plus 4, and then r squared plus 4. So expand it all out and collect like terms. And when you do, you will get the following. You will get PQR all squared plus 4 PQ squared plus PR squared plus QR squared plus 4 times P squared plus Q squared plus R squared, and then finally you'll get a 4 to the power 3. Now at this point, we can't make the direct substitutions with these guys. Wish we could, but we can't. So we have to do a little bit of modifications with what I call fancy algebra, but it's not too fancy. It's a lot of it is just some basic stuff that you would just have to apply. The PQR, actually, we can. That's right there, so we'll just put that in there for now. But the rest of it has to be modified a little bit. And you can do it by modifying it as follows. PQ plus PR plus QR all squared minus 2PQR times P plus Q plus R. So that took care of this guy. And then plus 4 squared I think this was a 4 squared, sorry about that. P plus Q plus R all squared minus 2 times PQ plus PR plus QR, and then the 4 cubed just remains as is. Now at this point we can make the substitutions from our vietas. So the first one we already did, that was minus 3 squared. 4 times this guy, that's just this one, so it'd be minus 1 all squared. Minus 2 PQR, that's this guy up here, so that would be minus 2. And then P plus Q plus R, that's, wait, hold on. PQR is minus 3. And then P plus Q plus R, that's minus 2. Okay, so that takes care of that. And then the next one, 4 squared, the P plus Q plus R, that is minus 2. All squared. And then minus 2 PQ, that whole thing, that's minus 1 from this guy up here. And then we have at the end that 4 to the power of 3. And then this is basic algebra. I'm sure you can do that. When you crunch out all those numbers, you will get 125. 125 is the answer, and that would be D. A set of 12 tokens, 3 red, 2 white, 1 blue, and 6 black, is to be distinguished at random to 3 game players, 4 tokens per player. The probability that some player gets all red tokens, another gets all white tokens, and the remaining player gets blue tokens can be written as m over n, where m and n are relatively prime, positive integers. What is m plus n? So the probability that we're looking for is always stated as follows. A specific condition, in this case it's been described in the question, over the total. So what I'll do is figure out each of these, and then we'll come back and plug it all in. All right, so the total is something I would concentrate on initially. We have 12 tokens, right? So, and they're going to be given to 3 players. So player 1, player 2, and player 3. Each will get 3. Each will get 4, sorry. 1, 2, 3, 4. 1, 2, 3, 4. So initially, there's 12 factorial ways of distributing those 12 tokens, right? You have 12 choices for that guy, and then 11 choices for that guy, and 10 choices for the next one, and so on. But that overcounts tremendously because we have to divide by the overcount. Now, the overcount happens because in the first set, we're actually going to have 3 R's, right? R, R, R. In the second set, we're going to have 2 white. And the third set, we have 1 blue, I believe. Yeah, 1 blue. So I'll just put B for blue. And then we have 6 black, so I'll just put BL for all the tokens that are black. Like that. So as you can see, the permutations need to be placed in the denominator so that we adjust for the overcount. So the R's, since there's 6 permutations, it's really 3 factorial, right? Because you have 3 choices for the first guy, second choice, two choices for the second guy, and 1 choice left over for the third one, assuming that these tokens are different. They're the same color, but they would be R1, R2, R3. I can even put that in there, R1, R2, R3, like that, just to illustrate that they are indeed different. W1, W2. For the blue, there's only one, and then we can put 1, 2, 3, 4, 5, 6 for the black tokens. Okay, for the white, to adjust for the overcount, it'd be 2 factorial, and for the blue, well, it's just 1 factorial. I can put it in there, and for the black tokens, it would be 6 factorial. So that takes care of all the permutations. Yeah. And therefore, this is the total, and that would eventually go here. So now we turn our attention to the specific condition, and that's a little bit more complicated, so we have to talk about that with a little bit more detail. Okay, so specific condition is basically written in the question, and I've illustrated it up here, that it must be distributed that way. We have player 1 getting all 3 reds, player 2 getting the 2 whites, and player 3 getting the blue one. But even that is not the best way of describing it. A player gets all 3. You see what I'm saying? Yeah. Some player gets all 3. They're not saying player 1. So we'll discuss that. So here we go. We've got player 1, player 2, and player 3. Now, player 1 needs to have 3 reds. So that means for the, how many reds are there? For the 4 tokens that he's distributed, 3 of them must be red. So from 4, you have to choose 3 of them to be red. That takes care of the red. Player 2, from the 4 tokens that he gets, 2 of them have to be white. That takes care of the white. And for player 3, from the 4 tokens he gets, 1 has to be blue. Okay. Now that is fine, but you have to remember this has 6 permutations, because P1, P2, P3 could also be P1, P3, P2, right? And then there's an additional 4 permutations. It's basically 3 times 2 times 1. So that has 3 factorial permutations. So that is the total number for the specific condition. And now we have to basically put this on top. 4 choose 3, 4 choose 2, 4 choose 1, multiplied by 3 factorial. And then the denominator is this total guy. So that's 12 factorial all over 3 factorial, 2 factorial, and 6 factorial. Okay. And then now we just have to crunch out this number, and then eventually it'll be a fraction, and then we can answer the question. So let's do this. 4 choose 3, I believe, is 4. 4 choose 2 is 6. 4 choose 1 is 4 times 3 factorial, which is 6. And the denominator, the numerator in the denominator, we have a whole bunch of stuff here. And this 12 factorial and the 6 factorial, those I can cancel, because that'll just be 12 times 11 times 10 times 9 times 8 times 7. And then the 6 factorial cancels with the remaining numbers. Then we have 3 factorial, which is 6, correct? Yeah. And the 2 factorial, which is just 2, right? Yeah. Okay, and then we invert and multiply, because remember, this was a fraction. So it was 4 times 6 times 4 times 6 times 2, and then all over this 12 times 11 times 10 times 9 times 8 times 7. Okay, and then now however you want to do this, it's really up to you. Like, for example, let's see here, what can I do? I think that 2 we can cancel with the 10 to give a 5, and then the 6 times 4 times 6 times 6, 6 times 4 times 6 times 6, all this is 864, and so is 12 times 9 times 8. 12 times 9 times 8 is 864. So that all cancels. So when it's all said and done, the only thing that's left is the 4, the 11, a 5, and a 7. And therefore, when you expand that, that would be 385. And that is my m over n. And if you recall, they wanted m plus n. So that would be 4 plus 385. And that is 389. 389 is C. Integers a, b, and c satisfy ab plus c is 100, bc plus a is 87, and ca plus b is 60. What is ab plus bc plus ca? All right, so we got a system of equations here. System of equations. Okay, shouldn't be too bad, hopefully. So the first one is ab plus c is 100. The second one is BC plus A is 87. And the third one is CA plus B is 60. Got it? So the first thing I'm going to do is isolate. So this will be C is equal to 100 minus AB. A is equal to 87 minus BC. And B is equal to 60 minus CA. Okay. And they want this, right? So, well, let's see. Let's add all these guys. If I do, I get AB plus BC plus CA plus A plus B plus C. And that would be 160, 247. I just added 1 plus 3 plus 1 plus 2 plus 3. Okay, so far I'm not sure if that, I'm pretty sure that's pretty good. I mean, I hope it is. Now, I'm going to need a little bit more of these operations here. 1 plus 2, if I add those two guys, I get AB plus BC plus C plus A, and that's 187. The good news there is that factors. So we have A plus C, and we have B plus 1, right? A, B, C, and C. Yeah. And then this 187, we have to factor that also. So that there's a few possibilities. 11 times 17, or negative 11 times negative 17. And therefore, if we just look at B plus 1, it could be either 11, 17, minus 11, or minus 17. So that means B is either 10, minus 12, 16, or minus 18, right? If you equate them, if B plus 1 is 11, that means B is 10. If B plus 1 is negative 11, then that means B is minus 12, and so on, right? 17 and minus 17. In the same kind of way, hopefully we'll get the solutions for B again. If we subtract them, 1 minus 2, that gives me AB plus C minus BC minus A, which is 100 minus 87. And that's going to be A minus C and then B minus 1, which is 13, is equal to 13 times 1. And then therefore this will be minus 13 times minus 1. Got it? So by the same sort of principle, if you let B minus 1 equal these guys, you'll get values. So for example, if B minus 1 was 13, that means B is 14. If B minus 1 was minus 13, it would be minus 12, and then so on, 2 and 0 for the other guys. So then now let's look at this. We want, obviously, the same value of B, right? It's all part of the same system of equations, so B has to be consistent. And there's only one value that appears in both of those. And which one is that? It's the minus 12. So that means we can conclude that B is equal to minus 12. Okay. Almost done here. I think I might be able to keep it in the same screen. Or no, I'm going to have to move it up. That's okay. Okay, so then, since we have value for B, we can go back and try to figure out A plus C. So let's plug in there. So it'll be A plus C, putting minus 12 for B. So that means A plus C would be minus 11, so that's going to be minus 17. And then I think that's it. I think that's the only thing I need. Last piece of the puzzle. Yeah, I think that's it. So I'll just go back here and just work with that. So this is what we're trying to figure out. So AB plus BC plus CA. A plus C, so this and this is minus 17. And then B is minus 12. And there we go. And then when you solve for this, AB plus BC plus CA will be 247 plus 29, so 276. And this is what they wanted. If you look at the question, they wanted this guy right here. So 276 is the answer, and that's going to be D. On top of a rectangular card with sides 1 and 2 plus root 3, an identical card is placed so that two of their diagonals line up, as shown. Continue this process, adding a third card to the second and so on, lining up successive diagonals after rotating clockwise. In total, how many cards must be used until a vertex of a new card lands exactly on the vertex labeled B in the figure? Okay. So let me try to explain this. We have already made one rotation, and that one rotation, as you can see here in the diagram. Now, what they're saying is they want you to continue basically rotating by adding cards, and eventually they want a vertice to end up back on itself. So for example, this B right here, let's just concentrate on that guy. That's a vertex of the original card, right? Now, when we place this first card, this identical card, you can kind of think of it. I actually don't know why they keep talking about additional cards. You know, they're saying they placed an identical card, and then they're placing a third card, and so on. Because the question is really just rotating the same card. You see what I mean? If you took the original card and just rotated it, you'd get to that slanted card, and then you rotate it again and in the same kind of way, and you get a second rotation, and so on. So what we're really interested in is how much did you rotate it by? So what we need to do is, I'll illustrate it by drawing a line from the center to the vertex B. So I think the center, let me just see here, would it be approximately, let's say approximately here, that blue line I just drew. So why did I draw that blue line? Well, to illustrate that when we went from B to here, we really went from here to here, that angle, this angle, and I'll just call that angle theta. Got it? So we went from B to A. The vertex was originally at B, that vertex in the top left corner. And then now the vertex is at A, and that happened with a rotation of theta degrees. Now they want a vertex to let's see here. Let me read the question again. How many? Let's see here. How many cards must be used until a vertex of a new card lands exactly on the same vertex labeled B in the figure? Okay, I got it. Oh, basically what they're saying is how many times do you have to rotate before the card ends up not necessarily back in its original position, but just a vertex. So this card, like for example, that we just have with just one term, the vertexes are there, there, and there, and there, right? Those 4 red dots. If you keep turning it, when does it next land back at B, a vertex of the rotated card? So that would happen if you rotated 180 degrees. So if we knew what theta is, we can just divide that, and that would give me the number of rotations. Yeah. So I think I'll illustrate that with a nice diagram. So let me show you. So this diagram is very, very nice. I think it's very helpful. As you can see, it's basically showing you what's up here, but then it shows you kind of like what happens when you keep rotating. Currently, B is here, right? And when you made the first turn, which is shown by the yellow rectangle, the original rectangle is in green, B goes from here to here. Now what we're saying is, when would you, if you keep rotating this, when would you end up back on the green rectangle? Okay, well, it looks like the first time would be when you get to here. Eventually, as you keep turning that, I guess that yellow box, it's eventually going to end up with a vertex. Let me just draw in a line to kind of show. It'll be kind of like this, like that. You see what I mean? You'd have, yeah, it wouldn't be identical, obviously, because but the vertex would at least land back on the original, and exactly what the question is saying. Until a vertex, right here, this line, until a vertex of a new card lands exactly on the vertex labeled B in the figure. Yeah. Okay. So from this diagram, you can see we went from here to here, that's the first turn. From here to here, that's the second turn, third turn, fourth turn, fifth turn, and sixth turn. So 6 turns is the answer, but I am completely aware that you do not have this diagram to your disposal. So you actually have to painstakingly figure out that angle. And I'll do that for you to show you that the angle is indeed 30 degrees. And then therefore, when you did it this way, it would be 180 divided by 30, which is 6. But it's important for me to show you how to get that angle. Okay, so let's show you how to get that angle. First, I'm going to have to draw a line like that, and then that will help me. Okay, so using that diagram, I'm going to use tan. The tan of not theta, but theta over 2, because I'm really looking at the angle from here to here. Let me draw that again. From here to here, just half of that guy is going to be, did they give me dimensions? Yeah, they did. So this side is 1, and this side is 2 plus root 3. So tan of just that guy would be a half over 2 plus root 3 over a half. Yeah. And this actually will allow you to get the theta. Now, it's not that simple because you're not allowed to use calculators, right? If you use calculators, this was an absolute piece of cake. This, with the help of a calculator, could easily be calculated as theta equals 30. So you have to do a little bit of, I guess, work. When you crunch all these numbers out, you actually get 2 minus root 3. Now, unfortunately, unless you're an absolute, genius when it comes to trigonometry by memory, you're not going to be able to figure out that that is 30 degrees. At least I don't think so. So unfortunately, you've got to use a trig identity, and in particular, it's this one. And this is a relatively well-known one. It's tan A minus tan B all over the 1 plus tan A times the tan of B. And then what you do is you use some well-known values. So it would be 45 and 30. Most people will remember those. And you crunch out those numbers. So it'll be the tan of 45 minus the tan of 30 plus 1 plus the tan of 45 and the tan of 30. So a lot of people will definitely remember what is the tan of 45. The tan of 45 is 1. And the tan of 30, that is 1 over root 3. 1 over root 3. And you can easily get this. You can just draw those triangles. You can draw a triangle that has 45 degrees, and of course that's going to be 45 degrees. So that would just be 1, 1, and root 2. And then this 30 degrees, you can just draw a 30, 60, 90 triangle. And everybody knows that the ratio is 2, 1, and root 3. So just from that, you would be able to get these guys. And then just plug them in. And when you plug them in and crunch out the numbers, you'll get 2 minus root 3. And this side, well, that's 15. So that basically means that this theta over 2 is 15. And if theta over 2 is 15, then theta is 30. So that's another way. So as you can see, it's actually a pretty... When you look at the diagram, it seems pretty straightforward. But of course, the diagram is not offered to you in the question. You actually have to crunch out the angle. So the angle is 30, and therefore that would mean the number of rotations is 6. And that would mean the answer is A. Cyclic quadrilateral ABCD has lengths BCCD is equal to 3, DA is 5, and angle CDA is 120. What is the length of the shorter diagonal of ABCD? Okay, so first let's draw this. I have no idea what it looks like, so it's going to be a total sort of guess with regard to how this is even going to be drawn. So there we go. Let's just draw a circle and then let's just ad-lib here. So let's just say that's the BC, and then here we go. CD. And there we go. Okay. So let's label it B, A, C, and D. Not the most straightest lines, but it's okay. All right, so we now have to see what we can do with labeling these guys. I think the question gives us a little bit of information. This is 3 here. That's 3. That's 5. And I think that's it. And then they give us an angle, CDA. Oh, CDA. Okay, so that's a little bit different. So I'm going to have to draw a line. From C to A. Yeah. And then that angle is 120. Oh, wait. Hold on. CDA. Yeah, this angle is 120. Okay. All right. So now we have to figure out the length of the shorter diagonal. So the shorter diagonal, I assume, is referring to B to D. This guy. All right, so this question, I believe we are most likely going to have to use law of cosines. Law of cosines, it kind of screams law of cosines because of the angle and the two sides. All right, so let's see here. AC squared is equal to 3 squared plus 5 squared minus 2 times 3 times 5 cos 120. That's the most obvious one. And then when you crunch out these numbers, you'll get AC equal to 7. So that means that diagonal is 7. Now, if they're asking for that diagonal, we'd be done. But they're not. They're asking for the other one, the shorter diagonal, which I drew in red. Okay, so now we have to do this again. In the other triangle, ACD, that we have 3 sides. So that will allow us to figure out an angle. And which angle should I concentrate on? I'm going to concentrate on this angle right here. That one. So that would mean 3 squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 cos theta. And when you crunch out these numbers, you get cos theta is equal to 13 over 14. Okay. Now, at the very beginning of the question, they said that it's cyclic. So using the properties of cyclic triangles, or cyclic quadrilaterals, I should say. Let's see here. This angle, hold on, let me write. C and D, right? When you subtend, you get an angle theta. But if you subtend an angle from the same 2 points, you also get this angle. You see what I'm saying? And that angle will be equal. So that's, I guess, a helpful property of a cyclic quadrilateral. And that helps because now we can use triangle BCD. And I'm going to actually draw that triangle here. to avoid getting that diagram messy, where this is B, this is C, and this is D. Now, it's 3 and 3, so that means it's isosceles, I believe. And then when you draw a line down the middle, this will be equal to that. And this angle is 120. So this is a right angle. And therefore I can figure out BD. Yeah, I can actually probably just use cos. I don't have to use the whole law of cosines anymore. Cos of theta would be adjacent. So that would basically be BD over 2, this part, over 3. Correct? So cos of theta would be, well, first of all, theta we know is 120. So that's cos of 120. And that's, hold on, wait. Sorry about that. That 120 isn't, 120 is not theta. 120 is up here. Cos of theta is right there. So I can just put 13 over 14 there. You got to make sure I do this properly. And then BD over 2 divided by 3, that would just be BD over 6. And then when you crunch out these numbers, that would be BD is equal to 6 times 13 over 14. And let's see here, that'd be 3 times the 39 over 7. And I think that's what they wanted, right? BD, from B to D, 39 over 7. And therefore the answer is D. Points P and Q are chosen uniformly and independently at random on both sides AB and AC respectively of equilateral triangle ABC. Which of the following intervals contains the probability that the area of triangle APQ is less than half the area of triangle ABC? Let's make a quick sketch of an equilateral triangle, and I will label it ABC. And then they are saying that we choose some points. So I'll just say this is P, and let's just say this is Q. Some points, independently, randomly, on those sides AB and AC. And then they create this triangle APQ. So APQ, I guess, would be that triangle. And then what they're saying is, let's just call this area A, and let's call this area B, I guess. So what they're really saying is, what is the probability that the area of APQ, which in this case I've represented by A, is less than half of ABC. So ABC is the full A plus B, and then divide by 2 to get half. Now, that's really what they're saying mathematically, if you take their sentence and convert it to an inequality, I guess. Okay, so how do I do this? Okay, so the first thing I'm going to need is an angle. So this angle in here I'll call theta, that angle way up there. And we're going to use this property. I'm just going to put it in, actually. Some of you might have forgotten it. It's fairly well known that you calculate the area of a triangle using trigonometry. So area in this case would be 1/2 AB sine C, C being that angle, in this case theta. So it's the equivalent of saying AB sine theta. Okay, so let's do that on this triangle the best that we can. Okay, so using this, okay, so A would be the area of triangle APQ. So using this formula, that would be, oh, I don't have anything labeled here. So it's an equilateral triangle. How much do I have to label? I'm just going to use a unit equilateral triangle because I don't think it matters, because when you're doing ratios, it'll cancel out. So just say 1, 1, and 1. And then this AP I'll call X and AQ I'll call Y, because that I have no idea what it is, because that could be anything based on where you placed P and Q. So using that, it'll be 1/2 AP AQ is sine, well, it's an equilateral triangle, so all the angles are 60. And then less than the whole triangle, ABC's area, so that would be 1/2 1 times 1 times the sine of 60, and then all over 2 to account for that 2. Okay, now let's substitute in our x and y, so that's going to be x, y, sine of 60. Well, the sine of 60 is on both sides, so that cancels out, so does the halves, and then that will just be a half. Okay, and therefore y is less than 1 over 2x. And then the parameters for x, that it's got to be between 0 and 1 based on what I labeled, the sides, and y has got to be between 0 and 1. Okay, at this point we will use a graph, put on the coordinate axes, so like this. So we're going to use basically this. We're going to try to plot that, and that will help me figure out. So the graph of y is equal to 1 over 2 over x. You guys remember this graph, y is equal to 1 over x. It's kind of like this, if I remember correctly. And that's just in one quadrant. I think there's also another part on in the other quadrant, the third quadrant, I think. But we're only interested in the first quadrant because of our parameters. So 1 over 2x would be very similar, but it looked pretty much the same, I think. You just have a 2 in there. So I'm going to try to graph that. First, let me put in my parameters here. So I've got 1 and 1. So let me just put that dashed sort of to illustrate that that's my parameters. And then I can actually graph this fairly quickly. This y is, let's just say y equals 1 over 2x. So when x is 1, it would be a half. So that's right there. Well, this is 1, right? This is 1. And then when x is a half, it'll be 1. So it's going to be something like this. Oh boy. How do I even graph this? Kind of like that. Very similar to that, but you guys get the idea. Now, if we want it less than, basically what we're saying is we want this region. We basically want that region within those parameters. So let me just draw a closed area to let you illustrate, to let you see. That is what we want. We basically want the area of that. Now, the area of that is going to be a little bit difficult to figure out, to be honest, unless you used calculus, and I'm not going to use calculus, partly because I don't remember calculus, even though I did take it in high school about 32 years ago, I think. But we can approximate. And approximate by drawing that line right there. And if you draw that line, we have a little bit extra. We have that extra stuff there, but that's okay. If we calculate the area of that thing, it'll be very close to what we want. And that's pretty easy. It's basically the area of a unit square minus this triangle. So that'd be 1/2 base times height. The base is a half. The height is a half. So that looks to me like 7 over 8. So 7 over 8 is an approximate estimate to that area. We only want the red stuff. 7 over 8 is sort of the red stuff plus the green lines. But 7 over 8 is very, very close. And we know that the actual red, what I'll just call it red area, is going to be a little bit less than 7 over 8. Okay, so where does 7 over 8 lie in these intervals? It's not in the, let me think about this, hold on. It's not in there. It's not in there, because 7 over 8 is what, about 0.875, I believe? Yeah. That's close, but not there. Ah, it's here. And it's not going to be in there because this is beyond 7 over 8. Okay, I got it. So, of all the ranges, I guess they gave me, D is the one that most likely the area of the red region will be inside.